we want to determine a possible equation for the given graph using the sine function. We will determine the equation in the form y equals a times sine of the quantity bx plus c plus d, where the absolute value of a is equal to the amplitude. If a is less than 0 or negative, the graph is reflected across the midline. 2 pi divided by b is equal to the period. Negative c divided by b is equal to the phase shift, and d is equal to the vertical shift. So looking at the graph, the first step is to recognize that the midline is y equals 1. Because the midline is y equals 1, we know the graph has been shifted up 1 unit, and therefore d is equal to positive 1. From here, we need to highlight one period of the graph to determine the values of a, b, and c. Remember, when graphing the basic sine function, we start at the midline, and then we have a maximum, then we're back to the midline, then a minimum, and then back to the midline. Of course, if a is negative, we would have a reflection across the midline. So looking at our graph, notice how if we start at x equals 0 and go out to x equals pi over 2, we do have a graph of one complete period of our sine function. So let's go ahead and highlight this part of the graph to determine a possible equation. But notice over this period, the pattern is midline, minimum, midline, maximum, midline, and therefore we do have a reflection across the midline. So for the next step, let's determine the value of a. Remember, the absolute value of a is equal to the amplitude, which is the distance from the midline to a maximum, or the distance from the midline to a minimum. So notice in this case, this length here would be the amplitude, which goes from 1 to 4, and therefore the amplitude is equal to 3. So we know the absolute value of a is equal to 3, but because we have a reflection across the midline, a is not positive 3, a is negative 3. And now we'll determine b using 2 pi divided by b is equal to the period. Well, notice how we have one complete graph of our sine function over the interval from x equals 0 to x equals pi over 2, and therefore the period is pi over 2. Because the period is pi over 2, we know 2 pi divided by b must equal pi over 2. And now to solve for b, we can cross multiply or multiply both sides of the equation by the LCD, which is 2b. So let's multiply both sides by 2b. Simplifying before multiplying, b divided by b simplifies to 1 here, leaving us with 2 times 2 pi, which is 4 pi, equals on the right. 2 divided by 2 simplifies to 1, leaving us with pi b. To solve for b, we divide both sides by pi. Simplifying, we have b equals 4. Now let's determine the value of c, where negative c divided by b is equal to the phase or horizontal shift. When graphing the basic sine function, we start along the y-axis. Notice in our case, because we highlighted this piece of the graph, we also start along the y-axis, and therefore the graph has not been shifted left or right, and therefore the phase shift is 0. Because the phase shift is 0, we know c must be 0. Notice when c is 0, we would have negative 0 divided by b, which is 4. Negative 0 divided by 4 is 0, giving us a phase shift of 0. So now we have enough information to determine a possible equation using the sine function. One possible equation is y equals a, which is negative 3, times sine of the quantity bx plus c plus d. Bx plus c would give us 4x plus 0, or just 4x. And d is positive 1, and therefore we have plus 1. This is one possible equation for the given graph. Let's determine a second possible equation that does not have a reflection across the midline, just as an extra example. So let's go ahead and clear this. And now let's highlight one period of the graph where there is no reflection across the midline, meaning the graph would follow the pattern of midline maximum, midline minimum, midline. Notice how we could start at x equals negative pi over 4 and move to x equals pi over 4, or we can start at x equals pi over 4 and go out to 3 pi over 4. Let's focus on this piece of the graph and determine a second possible equation. The midline is still y equals 1, and therefore d is still positive 1. The amplitude is still positive 3, but now because the pattern over this period is midline maximum, midline minimum, midline, which is the same as the basic sine function, a is positive 3, not negative 3. The period is still pi over 2 radians, which is this distance here, and therefore b is still going to be 4, since 2 pi divided by 4 is pi over 2 radians. But now we do have a phase shift, and therefore c is not going to be 0. Again, we normally start graphing the basic sine function along the y-axis, but focusing on this piece, notice how this piece of the graph has been shifted right pi over 4 units, and therefore the phase shift is positive pi over 4 radians, which means negative c divided by b must equal pi over 4, and we know that b is equal to 4, which gives us negative c divided by 4 equals pi over 4. Solving for c, we can multiply both sides by 4. Simplifying, we get negative c equals pi, and therefore c is equal to negative pi. Now that we have a, b, c, and d, we can determine a second possible equation that will give us the same graph. A second possible equation using the sine function is y equals a, which is now positive 3, times sine of the quantity bx plus c, which should be 4x plus negative pi or just minus pi, and then plus d is plus 1. Both of these equations will give us the graph shown below. I hope you found this helpful.